Okay, so to learn what a logarithm is, we're going to first review what we know about exponential functions. So if we sketch the graph of the exponential function with a base of 2, y equals 2 to the x, and we create a table of ordered pairs. So x, and then our y is 2 to the x. So if I percent y equals 2 to the x. So if I put in a negative 3, negative 2, negative 1, 0, 1, 2, and 3 as the x values, I'm substituting negative 3 in for x, and 2 to the negative 3 is 1/8. Then substituting negative 2 for the x, 2 to the negative 2 is 1/4. Then 2 to the negative 1 is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. And 2 to the third power is 8. So if I plot those points on my graph, then 3, 8, 2, 4, 1, 2, then the y-intercept is at 1, negative 1, 1/2, and then we're getting closer and closer and closer to a horizontal asymptote here along the x-axis. So the exponential function y equals 2 to the x will look like this. Okay, now when I go to look at its inverse, if you recall, an inverse is a reflection over the diagonal line y equals x. So that would be this dashed line on the graph. Okay, so that's my diagonal y equals x, and then to find an inverse, we take each of these ordered pairs and we switch the x and the y to cause that reflection over the line y equals x. So the inverse graph, I'm going to plot the points x comma y, where now my negative 3 on the graph is the inverse, the y value. So 1/8, negative 3 would be on the graph of the inverse. Then negative 2 would be the y of my inverse, so 1/4 would be the x, right? I'm switching these x and y coordinates to get the ordered pairs for the inverse. So 1/2, negative 1, then 1, 0, 2, 1, 4, 2, and 8, 3. So when I plot those points, switching the x and the y, right, this coordinate here at 3, 8 becomes a point at 8, 3. This point here at 2, 4 becomes a point at 4, 2. Then 1, 2 becomes 2, 1. Then 0, 1 becomes 1, 0. And then we have a 1/2, negative 1. Then 1/4, negative 2. And notice we're getting closer, closer, closer now. Instead of to the x-axis with a horizontal asymptote, we're approaching the y-axis with a vertical asymptote. So the inverse of the exponential has a vertical asymptote and then is increasing through these anchor points. And just like for, if we review here for a second, inverses that we already know, so for y equals x squared, right, the inverse of a square, we had a special function with a new symbol called a square root. And a square and a square root are inverses, right? They undo each other, and their graphs are a reflection over the line y equals x. So when we look back here at our 2 to the x power, right, the inverse is going to require its own new notation. And so we call the inverse of an exponential a log. So we're going to use the word log, and then the base of the exponential will be the base of the logarithm, and we put that as a subscript. And then the exponent is going to be the argument of the logarithm. So y equals log base 2 of x is the inverse of y equals 2 to the x, the exponential. So these two graphs, these are inverse functions.